We are given a matrix P is this, is such that P is equals minus P transpose. If D is 2, then P is equal to. Okay, this just, if you could remember, the type of matrix we call skew symmetric matrix. A skew symmetric matrix is a matrix that represents once the matrix is equal to negative of its transpose, you call it a skew symmetric matrix. Call it a skew symmetric matrix. And how do you know a skew symmetric matrix? A skew symmetric matrix is assuming if P, let me use A, if A equals, if A is a matrix, how do you know it? The principal diagonal is 0, and whatever that is here is the negative reflection. So I'm saying that if here is A, whatever that is here is minus A. So this is a skew symmetric matrix. Or maybe if it's a 3 by 3 matrix, 0, 0, 0. Maybe if here is A, B, C, whatever that is here will be minus A, minus B, and minus C. So these are skew symmetric matrices. So with that now, they say that P is equal to, so A and C must be 0 for it to be a skew symmetric matrix. And since D is 2, what is here is minus 2. So our answer is C. So it's a skew symmetric matrix. So we are asked to find the matrix A such that AB is equal to I, where B is that, and I is a unit matrix. For the product of two matrices to be equal to an identity matrix means that the two is they are inverses of each other. So it's the only way that a matrix, the product of two matrices, to be an identity matrix. It must be the product, must be the matrix and its inverse. The product must give us an identity matrix. So from here, meaning that since B is this, A must be inverse of B. So which is the inverse of. And you remember, to find the inverse of a 2 by 2 matrix is very simple. Assuming you are given a matrix, maybe let me use a matrix P equal to A, B, C, D. This is P. The inverse is very simple. It's 1 over the determinant, and the determinant is AD minus BC times whatever that is here. You swap the principal diagonals, the elements of the principal diagonal. So it's D, A, and you negate the other diagonals, which is now minus C minus B. So without wasting time, the inverse of this matrix is just 1 over the determinants. That's 1 times 2, 2. 2 minus 1 times 1 is 1. And you interchange the elements of the principal diagonal, which is 2, 2, 1. You now negate the other diagonal, which is minus 1, minus 1. So the answer is 2, because 1 over 1 is 1. So 2. So that's the answer. That's our A. So the answer is 2, 1, negative. So the answer is B. The answer is B. So again, if this matrix times this matrix and is an identity, this is an identity matrix, then D is what? So I told you this is now the inverse of this. So our main aim now for the product of two matrices, and the answer is an identity matrix, meaning they are inverses of each other. So I'm saying that this matrix A, B, D, C must be the inverse. So we need to find the inverse, and remember the inverse of this 2 by 2 matrix is 1 over the determinant. Minus 2 times 3 is minus 6. Minus 2 times 2 is minus 4. So minus 4 is plus 4. So we interchange the elements of the principal diagonal, which is 3 minus 2, and we negate this element, which is 2 and minus 2. So we have minus 6 plus 4 is minus 2. So I have minus 1 over half, which is 3 minus 2, 2 minus 2. So remember, this is a scalar product, so I'll multiply each of these elements by half. So we have minus 3 over 2. This times this is 1. Minus half times 2 is minus half times 2 is minus 1. This times that is plus 1. So that's the matrix. Okay, remember we're asked to find D. So D is from here, D is, as you can see, D is this. So the answer is minus 1. So given that A is this and B is that, AB is this, what type of matrix? So let's find the product. AB is now 1, 2, 4, 3 times mx and y must give us 2, 1, 3, 4. So 1 times m is m plus 2 times 1 times m. We multiply row and column. So 1 times m is m plus 2 times n is 2n. Must give us these 2. Again, this row will multiply the other column, which is 1 times x is x plus 2 times y is y, 2y, sorry. Must give us the second. Remember, this multiplies this, so the second one, which is 1. So the other one, again, this row will multiply this, which is 4 times m is 4m plus 3 times n is 3n. Must give us 3. Again, finally, this row again will multiply the second column of this, which is 4 times x is 4x plus 3 times y is 3y. Must give us 4. So we have equation 1, 2, 3, 4. So we are going to solve this simultaneously. So we now solve simultaneously. So this m and n. So we solve equation 1 and 3 simultaneously. So using elimination method, so I'll multiply equation 1 by 4. So 4, this is 4m plus 4 times 2 is 8n. 4 times this is 8. So y equation 3 is 4m plus 3n equals 3. What I did, equation 1 times 4. So I call it equation 5. So solving equation 5 and equation 3 simultaneous. So we're using elimination. So equation 5 minus equation 3 is now implies that 4m minus 4m is 0. 8n minus 3 is 5n. And 8 minus 3 is 5. Therefore, n is 1. So find n choosing any of the equation. Okay, let's use equation 1 because it has a simpler. From equation 1, because we've gotten n, next thing is to find m. So m is now 2 minus 2n, which is 2 minus 2 times 1. 2 minus 2 is 0, so m is 0. So here again we'll solve, remember we'll solve the equation, we solve this and this, so we're going to solve this and this simultaneously, 2 and 4. But before then we are using elimination method, so I'll multiply equation 2 by 4. So 4 times x is 4x, 4 times 2y is 8y, 4 times that is 4. So equation 2 times 4, we call it equation 6. So I'm solving 6 and equation 4 simultaneously. So I'll now do by elimination. I'm using elimination, so we'll do equation 6 minus equation 4. So 4x minus 4 is 0. 8y minus 3y is 5y. 4 minus 4 is 0. So which implies that y is 0. So we now choose again, because we found the value of y, so we now find the value of x. So I will use equation 2. It has a lower value of the constant. So from equation 2, we now find x. X is 1 minus 2y, which is 1 minus 2 times 0. 1 minus 0 is 1. So the matrix we are looking for is now, remember the matrix is mx and y, ms and y. So therefore ms and y is now, m is the value of m is 0, m is 0, n is 1, m0 and 1, m0 and 1, y, x and y. X is 0, sorry, y is 0, x is 1, so 1 0. So the name of the matrix is, okay, it looks like skew symmetric, but they are the same. This is the same sign, so it should be non-singular. Non-singular. Do you remember the definition of a non-singular matrix? If the determinant is not 0. So once as you can see, the determinant is -1. So it's a non-singular matrix. That's the